Yes. Good morning or good afternoon. Yes. Good afternoon. All fine? Okay. Yes. All good. How was your paper? Okay. Good. How was exam? Done all the things? Everything? Done. Okay. Okay. Good. So, what happened? How to join group? You can send message to official number. Okay, they will add you in that group. Okay, sir, this week's syllabus also will be sent to you in the group. Okay, next thing, this week's syllabus it will come. Okay, whatever the syllabus will be there. Okay, whatever things will be completed that will be asked. Okay, like okay, last week from the gases nothing was asked in the paper. From gases, okay, not a single question asked. We don't know also. Are you know this thing? In the gases questions not came na? Why? Because in some of the batches, okay, in the girls it was not completed. So if something is not completed, okay, we'll ask next week, okay. Like this week, we'll start from the gases, okay. Means syllabus, of course, okay, a little bit, okay, sometimes more, sometimes less. It can be there. Means it is not that okay that while okay in rush of completing the syllabus we are missing the concept. It will not be like this. Suppose somewhere we can okay reduce the syllabus a little bit. Most important thing is the your concepts should be clear. Okay, whatever things we are writing, okay, that should be the perfect. So till now, okay, we have done the graphs. Okay, some of the graphs we have written. I hope all those graphs are clear to you. You don't have any single doubt in those things whatever completed. Yes, everything is done. Okay, so now today we have to do some questions on the ideal gas. Okay, ideal gas mainly we have to do the things. So okay, already you know that PV equal to nRT. Okay, so based on that we have to do some practice. Yes, so listen, can we start? Because okay, now official time starts. Maybe in the okay whenever my class will be there I will try to come early. Okay, when this is there na, then I will try to come early around 12. Okay, so if I come okay suppose 5 minutes 10 minutes early, okay, around 12 you can okay check all the time I will be live. Okay, so that okay we can get somewhat more time we can okay, because after 1:15 it is somewhat tough for you also because you might be feeling hungry. So okay, what we can do is starting little bit 5 minutes 10 minutes early and okay, because there is the okay some break time is there for me. I can okay come early and we can do some more questions also. So from the next class onwards, if my class is the last class, okay, then we can start around 12 12:05 like this. So we can say here in this one that we got first of all, if I have this sample, okay, and okay, in this sample we are having some molecules. You can say there are so many molecules here, okay, and now in this one, like this dot dot dot, I can say so many molecules are there. So we can say this capital N, okay, capital N we refer always, okay, number of molecules in the sample, okay. So we can say N is basically number of, okay, total number of molecules in the sample we refer as, okay, we refer as capital N, okay. Yes, sir, 0 centimeter mark and 20 centimeter, 100 centimeter mark at 100 degrees Celsius. This one is very easy question. Can you see? Try this one. 0 here 0 and here 20 and 100 at 100. Okay, this is a much easier question. You can do like this. Here 0 and here 20 and here 100 and here 100. This was the thing. Okay, and 60 centimeter mass. Here 60. Here you can say x. Then 60 minus 0 by 100 minus 0. X minus 20 by 100 minus 20. Can you try? Yes. Can we get this thing? Here 60 minus 0 divided by 100 minus 0, x minus 20 by 100 minus 20. Okay, you did the same thing. I hope you will get the things, okay, if you try this way. Maybe, okay, you are not able to get the question properly in the examination. Sometimes what happens, we are not able to read question properly, okay. So listen, N is the number of molecules, okay. And one more thing I'm saying, that read your questions properly. If you don't read the question properly, means that the, okay, if you want to become the good doctor, okay, how you will read the doctors basically? Not understood the question. Yes, how you will read the doctors? That doctor writes so many medicines, or will be having proper okay diagnosis, or will be writing so many examinations, so many, one doctor writing so many examinations, so many tests to do, one is giving so many okay medicines, and one is okay having okay accurate diagnosis. Which one is the best one? Dr. A, Dr. B, Dr. C. Dr. C, proper diagnosis. Dr. B giving so many examination to make some, okay. Dr. A basically giving so many medicines. Which will be the good doctor? Which one you will prefer? A, B, C? Of course, answer is C, okay. Everybody is saying C. Means if you want to become the good doctor, means your okay diagnosis must be very accurate. And diagnosis will be accurate whenever, okay, you will, okay, diagnosis means at that level means here we are reading the question. So if you are able to, okay, diagnosis of the question means you are writing each line, okay, each line, what is given here, what is there, based on the symptoms only we have to, okay, find, our findings will be based on the symptoms, okay. So, okay, all those symptoms we have to listen. That's why first thing, most important thing for the doctor is that they have to listen carefully. First important thing is the listening. Second important is, okay, based on that they have to make some conclusion. Okay. So what we can say, yes, all good, chill. So we can say, okay, same, you have to read your questions properly if you want to become the good doctor. And okay, one thing I said, section B must be full by full. And section B, you have to get full marks. 40 marks means in physics as well as in the chemistry as well as in the biology. How much marks we are getting in the section B? In section B, are we getting 40 by 40 means all physics, bio, chemistry? Because in section B we have a choice, and how we can take wrong choice. Okay, if you are taking wrong choice means you can take wrong medicine also. So here our selection of choice is also important. Okay, so we need to learn this thing also, that section B, okay, either physics is there, either chemistry is there. I have to get anyhow 40 by 40. This is the first target I have given to all the batches. In all the batches I said this thing, that we are going to focus mainly on the section B. Section B must be full, because section A you will get. There is no problem. Are you getting what I'm saying? So, okay, proper reading. And second thing, this time, okay, we have to all time section B should be, okay, full by full in all, okay, in all, okay. I'm not only saying about the physics, it should be in the chemistry also, it must be in the your bio also, okay. Because I have seen people getting very less marks in the section B. When option is there, we can choose that question which we know properly, in which doubt is there, will not take that question. Why to take risk there? So now, okay, we can say N is the number of molecules here. If I say each, okay, small m is basically mass of each molecule. So mass of, okay, each molecule is your, okay, we can say small m. So if I say total mass of the sample, you can say so total mass of sample, okay, or we can say mass of the sample, okay. So we can write here in this one, mass of sample. You can write, sir, mass of the sample is nothing but the capital M. If mass of each molecule, one molecule is how much? Your M, and there are the N number of molecules, so we can say this is going to be M into N, okay. So mass of the sample becomes M into N. If I say here in this one, mass of, okay, if I say what is the Na? Na means how much? Na, you can write this is the, sir, this is the 6.023 into 10 power 23 molecules, okay, and these many molecules are basically known as your Avogadro number, that is your Na, okay. Means we can say this one is the 1 mole molecules also. Whenever you say 1 mole molecules, then you can say, sir, this is the 6 in power 23, okay. If I say mass of 1 mole molecules, then you can say mass of 1 mole molecule is known as your molar mass or molecular weight. Okay, so mass of 1 mole. Okay, so if I say mass of 1 mole molecule, so mass of 1 mole molecule we can say that is basically known as your molar mass or molecular weight, and we can write m into Na. So whatever I have written, basically PV equal to nRT we have to use today. And what is the problem that PV equal to nRT? Everyone knows. Okay, very simple formula, almost everyone knows. What the problem in this one, that they are not able to put proper values of pressure, volume. Okay, so before writing the formula, we are finding here what we have to take for the pressure, what we have to take for the volume. Okay, in what unit we have to take the temperature, what should be the R. These are the very basic things. Actually, we can say quite basic. But again, maybe you have done in the your chemistry basic classes also. Yes. Okay. In physiology class, listening your class. Arey, where? Who is this physiology class listening my class? In medical college. Which medical college? Okay, so we can say mass of total sample will be m into n, and here we can say mass of 1 mole mw will be m into Na. Okay, GMC. Okay, good, still there. So now we can say here in this one number of moles. So number of moles, if I say n equal to here in this one m by mw, and this is the n by Na. Okay, we can find the number of moles, that is the m by mw as well as n by Na here. Okay, now in this one m by mw or n by Na, mw, if I say, you have to again I'm asking very basic question, but here you do mistakes. Okay, so mw, if I say for the different gases, I'm going to write here mw for the hydrogen, how much? What will be the mw for hydrogen? I'm just asking. Okay, which year? GMC, in which year? Okay, 2. Okay, yes. So we can say basically, we can say this one is basically molecular weight is your 2 gram. For the helium, we can write this is the 4 gram, and we can write here in this one that is for hydrogen, helium. Okay, then next one that you remember is the oxygen, that is the 32 here. Then we can write for the nitrogen, it will be the 28 here. Okay, oxygen, when I said that O2 form, it will exist in the O2 form, nitrogen then O2. Okay, these are the some important gases that we have to use in our this chapter. This is the 44 gram. Actually, you should know mass of mass of almost all, but at least this thing you can do. Okay, if you do this much, that is also more than enough for us. So it is over. Okay, then comes the next thing here in this one, means after the MW, then we can say density is there. Okay, for the solid, actually, if you say solid, then solid we have only one type of density, that is the mass density. Okay, mass by volume. For the liquid also we have mass by volume, but for the gases we have two types of density, because for the gases two things are important. Number one is the your mass density, and number two is basically your molecular mass density. Number two is the molecular density, means molecule by volume, number of molecules by volume. So we can say density number one, I can write here in this one molecular density. Okay, so if I write here molecular density means nothing but the molecules by volume, number of molecule by volume. Okay, so we can see this one will write with the mu, and this is the number of molecule per unit volume, or N by V simply. Okay, that is your molecular density. And number two is coming here, that is the mass density. Okay, number two we can say that is the mass density here. So two types of density you have to remember, mass density as well as molecular density. Mass density we write as the rho, so rho equal to, we can say, mass by volume, that is the mass density here. And you will say, sir, m, you have told m into n, so I can write this thing as m into n by v, and n by v is what? N by v just now written here mu, so we can say rho actually becomes here m into mu. So this is the one relation between the mass density and molecular density. So two types of density are there. We have seen the relation also, rho equal to m into mu, molecular density, number of molecule per unit volume, mass density, mass per unit volume, and here we can say this one, number, okay, molecular density is also known as number density, okay, number density, or we can say your molecular density, okay. So in this one, just basic things therein, what are your, how to find the moles, how we will find the your density, what are your mass density, what are your MW. I hope this slide is clear now. Can we go for next? Going for next one, yes. Okay. Once we have done the density, then we have to write, okay, in the PV equal to nRT, okay, in the PV equal to nRT, first is your pressure. So pressure always you have to take in your Newton per meter square, or we can say your Pascal here, okay, SI unit. Now we can say 1 atm. 1 atm is basically 1.01325 bar, but roughly we can remember 1 atm is approximately equal to 1 bar, and which is equal to your 10 power 5 Pascal, okay. So if anywhere in the question 2 atm coming, then we have to take 2 into 10 power 5 Pascal, okay. And next thing that you have to remember in the pressure, we can write in the mm of Hg also. So 70, okay, 760 mm of Hg, okay, mm of Hg is same as 76 centimeter of Hg, and which is actually equal to 1 atm, and we can say 1 atm is nothing but the, okay, 10 power 5 Pascal, okay. So we'll take one question on this conversion later on, okay, means today only. 760 mm of Hg, I can say 76 centimeter of Hg, that is the 1 atm, and which is basically equal to 10 power 5 Pascal, okay. Yes, this one okay, up to this clear? Pressure things are done. Now after pressure, basically we get the your PV equal to nRT, means your volume, okay, and volume always you have to take in the SI unit, and SI unit for the volume is meter cube. Remember this thing, volume you have to take in the SI unit, which is the meter cube. You will never take the liter, you will never take the ml, okay. 1 liter, okay, 1 liter is equal to 10 power minus 3 meter cube, okay. So if anywhere question 5 liter coming, then we'll not take the 5 liter, we have to take 5 into 10 power minus 3. 10 liter coming, we'll take 10 into 10 power minus 3. And suppose they are giving centimeter cube or cubic centimeter, okay, centimeter cube or cubic centimeter means cc, cubic centimeter. Centimeter is 10 power minus 2, so if you take the cube, 10 power minus 6, 1 cc is also known as 1 ml, and which is basically equal to 10 power minus 6 meter cube. So these two conversion we are going to use for the volume, okay, okay, for the volume. And for ideal gas, you remember, okay, for ideal gas, okay, and real discussion of real gas will happen in the real gas, okay, means in the chemistry they will take this thing. So for ideal gas, volume we take always volume equal to volume of container, okay, volume of container, okay, we take, which molecule of ideal gas are very, very small. So for the moment full space is available, and volume is defined always free space of container where molecule can move, where molecule can move. So whatever the space is available, okay, in that space molecule can move, that volume we have to take. So volume is always free space of container where molecule can move, okay, freely. So for ideal gas we have to take always volume of container. If it is given in the liter or ml, then we have to convert into meter cube. So PV equal to complete. More also we have written. So now I will go to the next slide. I hope this volume thing is clear. Okay. So now I'll be moving to the next one. Then comes your R. R is basically nothing but the, okay, we can say this is a universal gas, okay, constant here, and this one is known as R. R is basically 1, okay, is R we can say, okay, and again in SI unit only you have to remember. So we can say 8.314 joule per mole Kelvin, but you will prefer calculation in the decimal of fraction. 8.314, okay, is there. You are going to do all the calculation, means most of the time your preference must be in the decimal or fraction. What you will choose? We choose always fractions. It will be much easier for us, okay. Calculation in the decimal, it will take some time. So in the fraction, this value is 25/3 joule per mole Kelvin, and lot of time I will use 25 by 3 rather than this 8.314. If you feel 8.314 will be cancelled directly, then only we can use 8.314, otherwise 25 by 3, okay? And in calorie, this value is 2 calorie per mole Kelvin. If anywhere in the option calorie word is there or in the question calorie is given, then we'll use value of R as, okay, not 8.3 or not 25 by 3, we have to use 2 calorie per mole Kelvin, okay. Then there was one man, there was the Boltzmann, okay. And what Boltzmann said that I will divide R with the Na. He said I will write R by Na, and R by Na I will say as one constant which is known as your Boltzmann constant. So we got here K equal to R by Na, and this one is nothing but your Boltzmann constant here. And okay, that is the K. For this for value, you have to remember, you can see here generally people do the mistakes in the power, okay. You can say sir R is 8.3, N is 6 into 10 power 23. 23 will go upside, so minus 23. So we can say it becomes 1.38 into 10 power minus 23. So this is the thing that you have to remember here, that it is not plus 23, it is a minus 23. And then comes last thing here, that is the basically your temperature, and in the PV equal to nRT, okay, or in this chapter we have to, or temperature anywhere we have to consider in the Kelvin, and we have this relation that Kelvin is equal to degree Celsius plus 273. Okay, if I say temperature change, I can here delta K, and delta K equal to delta C, which temperature change in the Kelvin and degree Celsius is always same. You remember, temperature change is same, not the temperature. Temperature change in the degree Celsius in Kelvin is always same, not the temperature. I hope this thing we are getting. Temperature change is same, not the temperature. Temperature change in the degree Celsius and Kelvin is always same, okay. So you can write this thing. Now we are ready for the PV equal to nRT. So in these 20 minutes, just we have done very basic things, okay. Now we can write PV equal to nRT, then okay, we can write some of the questions. But to start with the PV equal to nRT, this thing is required. Without this, it is not possible for us to solve questions correctly. Sometimes we do the mistake. If we are okay knowing these things, then chances are there most of the time your answer will be correct, okay. So we'll go forward now, and okay, if you have doubt anywhere, you can ask in the universal gas constant, in the Boltzmann constant, in the pressure conversion, in the volume conversion, or anywhere, okay. Yes, finished. Okay, listen now. So if I say PV equal to nRT, okay, this is the ideal gas equation, okay. Ideal gas equation. You might be thinking, some of you, sir, what are the okay ideal gas? Okay, so I can say okay, gases basically I can divide into two parts. One is the ideal gas, and one is basically your real gas. Okay, if I ask what is the ideal gas, okay, if I ask what is the ideal gas, that will be the same as R. Na is the number. Sajid, Na is the number, okay, so number is not having any, okay, unit, so we can take same, okay, R by Na, Na is the number, okay. So if I say real gas, okay, Sajid, okay, can I move forward? So real gas, don't say sir which are in the real, they are the real gases, and which are ideal, known as ideal gas, okay. I don't need this answer, okay. Sometimes I ask what are the ideal gas, people say that sir which is ideal, that is known as ideal gas, and which is there in the okay nature in the real, that is the real gas. Real is the real, ideal is the ideal. This answer, okay, I don't need. Actually what happens that when we were having discussion of gases, in the gases intermolecular forces are not that much strong, but it is there, okay. Intermolecular forces are there, okay. In solid, intermolecular forces are very, very strong. The liquid somewhat less, okay. And we can say in case of gases, intermolecular forces are there, but not that much strong, but it is there, okay. We saw on this molecule, we can say, so all other molecules will be having some interaction. So interaction there, however, this is not a very strong interaction. So in all other gases which are present in the nature, there are your real gases, okay. So intermolecular force is not zero, it is there, okay. Whatever the gases we have, that is the basically your okay real gas. Whatever the gases we have in the nature, they all are like you can say hydrogen, oxygen, anything you name, that are your real gas, okay? And for these gases, intermolecular force is not zero, okay? Means intermolecular force is not zero, it is less as compared to the solid. If you compare from the solid, in the solid it is more, in solid more, in case of gases it is less but not zero, okay? Now we can see how to study this particle, and under influence of these forces, for me it is not possible, because you have seen in the vector, if there are the more than 3 or 4 forces, more than 4 forces are there, suppose at a particle, okay, means at a point, or suppose okay, on a particle more than 4 forces are applied, can we solve that question? Of course we can solve, it will take time. Suppose okay, more than 10 forces are there, can we solve easily? More than 10 forces, can we solve easily? It will not be very easy for us. And here, if so many interactions are there, so many interactions we cannot, okay, solve easily. So we have to assume, okay, just assumption, that if these interaction becomes negligible, if these interactions are there for the real gases but not zero, okay, if these interactions become negligible means almost zero, okay, then we can how study properly. So we got, this is the concept, this is not the real thing, okay, just one concept, theoretical thing that we can make here, we can assume here intermolecular force is zero. This is the first concept, okay, and ideal gas is based on this conception only, that we assume intermolecular force is zero, okay, intermolecular force is zero, then we can say the ideal gas, or we can say intermolecular force are negligible, tending to zero, that is the your ideal gas, otherwise that is the your real gas, okay? Any problem here in this thing? Now you might be thinking, sir, okay, how we can make okay, intermolecular forces negligible? We can make these intermolecular forces negligible if there means interaction. Ultimately intermolecular force means interaction. Interaction will be less if molecules are far. If molecules are far, then interaction will be more or less. Two peoples are very close to each other, it means they are having a strong interaction, and if they are far, the interaction is very less, okay? So if they are far, the interaction will be less. So if I say, if I keep on increasing the temperature, if temperature of the molecule, if I keep on increasing, then interaction will keep on decreasing. Temperature increasing, interaction will keep on decreasing. And if interaction becomes less, then gas can behave like ideal gas. Means in the gases, basically we can say what will happen, your intermolecular forces will be negligible, okay? So we can write here, okay, again, when gas can behave like ideal gas, when temperature is high, okay? So at the high temperature we can say gas can behave like the ideal gas, or we can make the your intermolecular forces negligible. One condition we got, high temperature, okay? High temperature should be there, okay? If I say, okay, if if pressure, okay, if pressure is there, huge pressure is there, huge pressure, then molecules will be close. And if pressure is removed, okay, then some molecules going this side, some going this side, some going this side. So if pressure is huge, they will be having a strong interaction. Pressure is lesser interactions, we can say pressure should be low. So high temperature, low pressure, okay. And last condition is basically, if I say, okay, like these are the two molecules, okay, at this, and then same molecule if I keep in the, okay, in this, okay, now we can say here, okay, here interactions, in this case interaction will be more, here interaction will be less, here interaction less, because volume more means density. Here volume more means density, here volume more, interaction less, it means density here less, okay? So it's a low pressure and low density, okay? If density is low, it means volume will be more. Volume will be more means they will be far, okay? They will be far, okay? These interactions will be less. So at a high temperature, low pressure, low density, okay, we can say real gas behave like, okay, behave like ideal gas. Real gas behave like ideal gas, you have to remember, okay? So this is the thing, okay. Here we can say ideal gas will follow PV equal to nRT at all condition, okay, but real gas will follow PV equal to nRT only at the high temperature, low pressure and low density, okay. PV equal to nRT, the ideal gas equation. So ideal gas will follow PV equal to nRT all the time, but real gas will only follow whenever it will behave like ideal gas. It behaves like ideal gas only at these condition. Yes, done this thing. Now listen, I can see here in this one that your ideal gas equation is followed by ideal gas at all the conditions which is the PV equal to nRT. PV equal to nRT. Now we can say we have to analyze this equation. What are the maximum possibility? They can ask sometimes formula. They will ask ideal gas in the different version. So all the different version we have to see now. Okay, different version of the ideal gas. They will give you 4 options and they will ask which of the option is incorrect. It means three formula regarding the ideal gas will be correct and one will be incorrect. So we should know all the variations. So I'm writing here. You can say, sir, this side I can write PV equal to more is basically M by MWRT. And someone will say, sir, this side I will write PV equal to, N by Na into RT, because most 2 formula are there. One the M by MW and other one is basically your N by Na. I don't think that any problem is there. Yes. If I'm writing like what I'm doing, different variation, different version of this formula we are writing. Sometimes they will ask they will give 4 options, only formula given. So we should know all the formula. And as soon as I write this M by MW N by Na, you can say, sir, R by Na is K. R by N is K. So now we can write here in this one PV equal to how much here your N, KT. Now PV equal to NKT you have to use for PV equal to you have to use for what? PV equal to NKT we are going to use, they will say like this PV equal to NKT where N refers. PV equal to NKT where N refers. What are the N? We can say N is the number of molecule. In this formula we are going to use to find, number of molecule. Whenever you have to find number of molecule, we are going to use this formula, PV equal to NKT. Now I can say next thing here, P equal to, you can say, sir, NKT divided by V, and now I can write N by V, N by, that is your molecular density or number density, and this one becomes P equal to here, mu KT, So we got one more variation here. We'll say P equal to mu KT where mu refers. Then we can say mu refers here your molecular density or number density. So P equal to mu KT. Any problem here in this thing? This side. Then this side I will come. We can write here P equal to MRT divided by, we can write here VMW. Mass by volume, that is our density here. Mass by volume, that is our density. Mass density. So you say it becomes rho RT by MW. And from here I guess the density formula. So density formula will be PMW by RT. This formula anyhow you have to remember, density equal to PMW by RT. You might be thinking, sir, I will derive. Yes, you can derive, but this one you have to keep in the mind also. This is the PMW by RT. Rho equal to PMW by RT. PMW by RT. Anyone having any problem? Yes. Maruti Sai, you are also attending classes? Now chill, don't attend the classes. Go outside, explore the world. Missing physics. Now don't miss physics, Go and explore the world. So now we can say, and next year these people also are going to come. So we can say here in this one, P equal to mu KT. Rho equal to how much your? Rho is basically M into mu, Rho is M into mu here, Now we can write, if I say mu, so mu will be equal to how much your? Rho by M. So here I can replace in this one, that P equal to rho KT by small m. So from here we can say rho becomes your PM small by KT. And this formula, I don't know why, but a lot of time they have asked this thing, rho equal to PM small by KT. So all these formula you have to keep in your mind, that PM small by KT, PMW by RT, PV equal to NKT, Today, one time you will derive, okay? Suppose anywhere you are having confusion, you forget something, then we can easily find out these things. What will be the correct formula? So make it fast. If you have any doubt, you can ask here. Then we'll do the questions, okay? Then now we are ready to do questions on PV equal to nRT. Yes, over. If you want to ask something, ask fast. Then we'll move forward, okay? Completed? Okay, so now we'll go for, okay, next thing here. Question in this one, can you derive these things one time by yourself? Okay, so listen, question here, this is the first one. If density at point, okay, they have given this thing. If density at point A is rho naught, find density at B. Okay, so this is the question given, and for this question they have given here graph, and graph is given like this. So this is the P here and this is the T, and then we got like this. Okay, so in this one, this is the point A, this is the point B. Okay, graph is going like this. At A they have given here, sir, pressure P naught and temperature T naught, and here they have given in this one that this is the, okay, 2T naught, and here they have given this is the 3P naught. Okay, so now we can see formula of density is very simple. We can write here rho equal to, okay, how much? PMW by RT. Okay, rho is PMW by RT. At A we can see, at A we can say rho naught. Pressure is basically how much? Your P naught. Okay, so we can put here in this one P naught MW divided by R, temperature T naught. We can say this one as the equation number 1. Same way we can write for B. So you can write, sir, at point B. So at B you can write rho B, okay. And what the pressure at B, if you say, we can say 3P naught. So pressure is 3P naught MW divided by, we can write here R, and temperature at point B is basically 2T naught. So we can write here 2T naught. 3 by 2 I can take outside, so it becomes 3 by 2, and we can write P naught MW divided by here R T naught. So now we can say rho B actually, okay, rho B equal to, it becomes 3 by 2, and P naught, this is the rho naught, this is the answer here. I think we can do quite simple, yes, and we can do directly also, okay. We can do directly, sir, later on, sir, pressure 3 times, temperature 2 times, so 3 upside and 2 downside. So we got here this thing. And P and T directly, yes, P and T directly proportional only at the constant volume. Only at the constant volume. So Harshita, okay, P and T is directly proportional only at the constant volume, means this relation P proportional to T, okay, this is at the constant volume. Other than this, this is also correct, okay, this is also possible, this also possible, okay, this also possible, anything is possible. How many processes are possible? We can say that the infinite process possible, okay. So this thing is there only at the constant volume, and if volume is not constant, then anything is possible. And here we can say that volume is not constant in this question. And if density changing, it means volume is changing. P proportional to T is only at the constant volume. Other than this, so many things are possible, so many equations are possible. I hope this thing is clear to you, Swarshita. Sometimes we feel only, okay, P proportional to T is there. Anything is possible. If I say, okay, temperature increases, if I ask one question to you, temperature increases, then pressure always increases, true or false? If I increase temperature, then pressure also increases, true or false? Temperature increases, then pressure also increases, true or false? You have to say this thing. False, okay, it is false, because so many things are there, okay. I can have any relation like this also, okay. I can get relation this way also, sir, P proportional to 1 by T, relation can be there, okay. Temperature more, pressure less, but in this case volume is not constant. When volume is constant, then P proportional to T will be there, okay. This is at the constant volume. Other than this, so many things are there, okay. Clear this thing? Infinite process exists in the thermodynamics. I will tell you that, okay, infinite process. Huh. But here volume is constant, okay, in this relation. I hope this thing is clear. Completed this thing. Ask if you want to ask something. If you want to ask something, okay, ask fast. But if I say like this, in closed container, temperature double, then what will be the pressure? In closed container, okay, closed container, temperature double, then pressure also? Then pressure also double, because then we can use closed container means volume constant, okay, closed container means volume constant, closed container volume constant, then we can say this thing, yes, P proportional to T, temperature double, pressure double, okay. But if I don't say okay, closed container, if I don't say container same, if I don't say your okay, volume constant, then we cannot say always P proportional to T, okay. Now we are writing next question for the number of molecules. So can we write next question? So this is the question here. Find number of molecules per cc number of molecules per cc. It means in this question, okay, if you see volume is given here, okay, that is, okay, if you say volume is per cc means your 1 cc is equal to 10 power minus 6 meter cube. So I have to take this thing per cc at 27 degrees Celsius and pressure 190 into 10 power minus 5 mm of Hg. So this is the temperature and pressure values given. We have to find the number of molecule. So we say temperature 27 is given, which is actually your 300 Kelvin here, and we can say pressure value, that is the 190 into 10 power minus 5 mm of Hg. So there is no problem, PVT given. We can use directly formula PV equal to NKT. So you can say, sir, this is nothing. I will write here PV equal to NKT. I need to find here N. So I can say N will be equal to, in this one, PV by KT. Now how to put pressure value, volume value, all the value how to put, I will get the answer here. Can you find answer here? Can you get the things? Yes. Actually, if I say na that okay, do, then what will happen, that most of the people will get wrong answer. And what are the reason? Because volume you have converted here, temperature you have converted. Now this mm of Hg must be converted, and here we do the mistake. So here, okay, we are going to do this conversion. We will write 760 mm of Hg is actually equal to, okay, 760 mm of Hg is actually equal to 10 power 5 Pascal. So we can say 1 mm of Hg. So 1 mm of Hg, if you take, that will be equal to 10 power 5 by 760. I am using unitary method here. So we can say 190 into 10 power minus 5 mm of Hg. Okay, if I take this mm of Hg, then we get this becomes how much? You get 10 power 5 divided by 760 into, we can write 190 into 10 power minus 5. Now 10 power minus 5 plus 5 will be cancelled. 190 and 760 if you solve, then will be coming H. Yes, how much? We can say this will come as 1 by 4. Okay, so we have to put 1 by 4 Pascal. Okay, and this is the one mistake people are generally doing. Now I can write here, now nothing is left. Pressure I can write 1 by 4. Volume I can say 10 power minus 6. K value we know 1.38 into 10 power minus 23. Temperature 300. And I hope you can do the calculation. Calculation is, okay, quite simple here. Can you move forward for next question? Next questions, yes. Now next question that we are having is based on the percentage. They can say percentage change at the constant volume, at the constant pressure or constant temperature. First we'll do these things, then we'll do, okay, for any other process also, suppose temperature change is coming. Ready? Okay. So okay, I hope this one is clear. Like this questions, if okay, coming anywhere we can do. Okay, so listen, if I say at constant volume, you can say, sir, at constant volume, just now, okay, we were discussing that P proportional to T. I can use the change method. So change method is saying delta P by P equal to here in this one, okay, delta P by P, we can write, okay, equal to delta T by T. If I say for the percentage change, then you can write here 100, and here also we can write 100. Okay, so percentage change in pressure and percentage change in temperature both are same. Okay, percentage change of pressure and percentage change of temperature both are same at the constant volume. Same way I can write here in this one that at constant pressure, so at constant pressure we can say, next thing we can write V proportional to T, so we can write here delta V by V into 100 must be equal to here in this one delta T by T into 100. Okay, means if temperature changed by 3%, we can say directly, sir, volume also changes by 3%. If temperature changes by 5%, we can say pressure also changes by 5%. Means whatever the percentage for the T, same percentage for P. Clear these two things? Then comes here pressure, you're at constant temperature. At constant temperature, we can say in this one that P is proportional to 1 by V. Now, this relation is not direct relation, okay? And when things are not direct, okay, then we can say this one, we can take upside. So, P proportional to V power minus 1. And then we can write delta P by P should be equal to minus delta V by V. And for the percentage, we can write into 100, okay? And here we can write how much here into 100, okay? But this is, okay, this relation is not direct. So this thing is only applicable up to 5%. If more than 5% is coming, then we'll use the other method, okay? Up to 5 only we can use. Actually, you can use this one for the 10 also, there is no problem. If options, depending on the option, if I say question, volume increases by 5%. Now we can say pressure decreases by 5% is the answer. Volume increases by 10. We can say pressure decreases by 10. There is no problem. Options you will see. Okay. If options are very close, one option 5, other option 5.1, next option 5.2, 4.9. If options are like this, then we cannot use even for 5%. We have to do the exact method. Okay. And for the suppose they are asking volume decreased by 10, it means pressure increased by 10. Option is 10, 20, 30, 40. Now we can use for that 10 also, there is no problem, okay? So like this is the things, okay? So you will see the options, whether options are close or, okay, we can take the approximations here. So completed this thing, let's write the question, okay? So one question I will tell on this, next question you will do on this topic and with this concept, and then I will tell on this, okay? By taking 5% I will take, then we'll see the things. So right, at constant volume, if temperature of a gas is changed by 5 degrees Celsius, its pressure changes by 2%. Pressure changes by 2%. Okay. Find initial temperature. Okay. They are asking here, find initial temperature. Okay. So at constant volume, we can say temperature is okay changed by 5 degrees Celsius and pressure changes by 2%. We have to okay find initial temperature. So we can say constant volume is given. Constant volume is P proportional to T. So we can write here delta P by P into 100 will be actually equal to delta T by T into 100. Okay, means percentage change of pressure is same as percentage change of temperature. Okay, then we get percentage change in pressure is given how much here? 2. Okay, this thing is given 2. Delta T, if you say in the question, given how much? 5 degrees Celsius. But I said we have to, okay, in this chapter, we have to keep everything in the Kelvin. Okay, you have to put in the Kelvin and you will get answer also in the Kelvin. So put in the Kelvin, get in the Kelvin. So now we can say 5 degrees Celsius change, and change in the Kelvin and degree Celsius is always same. Okay, change in the degree Celsius and Kelvin is always same. Change in the degree Celsius and Kelvin is always same. Okay, So what I can write here now in this one, that 5 divided by T into 100 equal to 2. So now we can say 2, this will be the 50. So T becomes here 250 Kelvin. But suppose answer is given in the degree Celsius. Then what we can write? We can write this way, 250 minus 273, which actually becomes minus 23 degree Celsius. Okay. So write this one. If any doubt is there in this one, then ask, because the next question you have to do. If any doubt is there, then ask. Next question you have to do. Yes, clear? So right, next question, okay, next question for you. At constant pressure, if temperature of gas at constant pressure, here constant pressure, okay, if temperature of gas is changed by 2 degrees Celsius, temperature changed by 2 degrees Celsius, is delta T is given 2 degrees Celsius. Temperature changed by 2 degrees Celsius, its volume changes by 0.5%. Volume changes by 0.5%. Volume changes by 0.5%. Find initial temperature. So we can say now in this one that here, okay, we can say V proportional to T, so delta V by V into 100 equal to, you will write delta T by T into 100, and delta T in this one is given 2 degrees Celsius, means 2 Kelvin. What is the answer? What is the answer? Yes. 400, yes, you got correct answer. 400 Kelvin, okay, because now we can say this value is given 0.5. 0.5 means here we can say half. Delta T is the 2 degrees Celsius, means 2 Kelvin, so 2 by T into 100. 0.5 means we can say half. 2 we can multiply, so it becomes here 400, okay, K, okay. 400 K, we can write this is the 127 degree Celsius also, okay. Can we write the next question now? Yes, next. Ready for next question? Next question we are writing at the constant temperature, okay? So, right. At constant temperature, if volume increases by 5%, then pressure, okay, now volume increases by 5%, then pressure. If I give you option, okay, pressure, okay, decreases by, okay, see the option, pressure decreases by, okay, 10%, pressure decreases by, okay, 5%, pressure increases by 5%, and pressure increases by 10%. These are the options. Pressure increase by 5, decrease by 5, pressure decrease by 10, increase by 10. Which one? We can say, sir, okay, volume increase by 5, it means pressure decrease by 5, okay, decrease by 5, yes. But options are not very close. We can say increase by 5, decrease by 5 is the correct answer, okay. Like this option given, then we can directly say. Otherwise, we will use, okay, suppose option is like this, okay, that 4.9, 4.7, okay, decrease by 4.9, decrease by 4.7, okay, decrease by 5.1. Then we have to solve exactly, and how we can do, we can say, sir, P1 V1 is equal to P2 V2 here, okay, I can say, sir, initial volume, whenever percentage initial we can take 100. So final volume we can say increase by 5 means 105. Okay. V1 is 100, V2 is 105. So I can say P, V1 is basically here 100. P2 is basically, okay, P2, V2 is your 105. So I can say P2 basically becomes in this one 100P divided by 105. Okay. This is the PT value, and then we can say percentage change. Okay. So percentage change is always given by, okay, we can say P2 minus P1 divided by P1 into 100. Okay, means for the this way, if the options are very close, then we have to find the final value. You can say, sir, this one I can simplify also. There is nothing but the 20P by 21. So we can write here in this one 20P by 21 minus P divided by P into 100. So we can write, it will be how much your minus? Yes, minus 1 by 21. PP will be cancelled into 100. And this one, if you solve, then minus 4.76%. Okay. So this is the, okay. So depending on your options, we'll take the things. Okay. If options are very close, then we can go like this. Otherwise, this is the thing. Okay. Completed. Over. This question is clear. This one clear now. When we have to do this process, when our options are very close, then only you have to do this process. Otherwise, okay, we can directly do. Over. Okay. So other questions we'll do in the next class. Okay. Yes. And maybe next class will start around 12. Okay. Next class we can start around 12. So from 12 onwards you should be ready. Okay. From 12 onwards, you must be ready. Okay. We may start around 12. Okay. If my last class is there, we'll start a little bit early. Okay. Bye. Okay. Now, okay. Enjoy. Do some questions on this part. Okay. Whatever we have done, very less question we have done, but okay. Okay. Try some of the questions on that part. Okay. Yes. Bye. Bye.